We will read Unit 19 today. So what is correlation and regression? That is the chapter, that is the unit. Unit 19, correlation and regression. So now we will look at the contents, okay. When we look at the contents, it is the 19.1, that is introduction, and 19.2 correlation, and 19.3 the method of calculating correlation and correlation of ungrouped data, and 19.4 method of calculating correlation of grouped data, and 19.5 regression, and 19.6 conclusion. So let us see what is learning objective. It is expected that after reading the Unit 19 you would be able to appreciate the relevance of the analysis of covariation between two or more variables. We can also describe the different type of correlation, and we can also elaborate the methods of calculating correlations of both grouped and ungrouped data. Also can able to understand the method of regression analysis that help in estimating the values of a variable from the knowledge of one or more variables. 19.1 Introduction. In the concluding section of Unit 18, we mentioned the linkages between propositions. Let us now discuss the subject of correlations and regression. Unit 19 is about correlations, that is an analysis of covariations between two or more variables. You would notice that the statistical tool of correlations help to measure and express the quantitative relationship between two variables. Unit 19 elaborates the ways of applying the tool. It shows the relevance of coefficient of correlation, coefficient of determination, and regression analysis in the social sciences. Further, it explains regression analysis, which is the method of estimating the value of a variable from the knowledge of one or more variables. The unit tells you to use the statistical tools of correlations without fear or apprehension that its application is difficult and complex. 19.2 Correlation. Correlation is an analysis of the covariation between two or more variables. When the relationship between the two variables is quantitative, the statistical tool for measuring the relationship and expressing it in a brief formula is known as correlation. If a change in one variable results in a corresponding change in another, the two variables are correlated. Let us look at types of correlation. Types of correlation. Probing into the type of correlation, we contemplate two types correlation. A, positive and negative correlations. B, linear and non-linear correlation. A positive and negative correlation. If the values of the two variables deviate in the same direction, that is, if an increase in the value of one result on an average in a corresponding increase in the value of the other, or if the decrease in the value of one variable result in a decrease in the value of the other, then correlation is said to be positive or direct. Some examples of a series of positive correlations are height and weight, land owned and household income. On the other hand, if the variables deviate in the opposite direction, that is, if an increase or decrease in the values of a one variable on an average result in a decrease or increase in the value of the other variable, then the correlation is negative or indirect. Some examples of negative correlations are: 1. Physical assets and the level of poverty, and muscle strength and age. With age, the muscle strength reduces. When the physical assets increases, level of property also decreases. If the physical assets decreases, the level of poverty also increases. So this is a negative correlations or indirectly. So figure 19.1 shows the positive and negative types of correlation. So you can see from here, A is positive correlations and B is negative correlations. So when one side it's increasing, the side automatically decreasing. So you can see here, when the value of this, whatever the parameters is at this point, this whatever the parameters in this axis is much more. When it this side when increases, automatically this side reduces. But in positive correlation, both the sides it increases. When value at this point is this much, if the value of this point increases, automatically the value of the other point increases. So this is increases, generally increases. Okay, that's the thing. The amount of increase is not exact proportion, but there is an increase. So this is the way the variables of a correlation range from -1 to +1. When r is equal to +1, it means that there is a perfect positive correlation between the variables. When r is -1, there is a perfect negative correlations. When r is equal to 0, it means that there is no correlation between the two variables. So this is one more graph for perfect correlations and perfect positive correlations and perfect negative correlations. Exactly perfectly. Whenever there is an increase, there is an increase in the other variable. Whenever there is an increase in other variable, one variable, there is a decrease in the other variable. Though this way goes the positive correlation and negative correlation. So about the linear and non-linear correlations, the correlations between the two variables said to be linear if corresponding to a unit change in one variable, there is a constant change in the other variable over the entire range of values. So consider the following data like x and y, and it is a constant change figuring in the entire range of values. So when we x increases, automatically y also increases. So we can represent this by a relations like that. When the value of y is equal to 1 plus 2x, you can apply this 1 here, you can automatically get the value here. So the equation is right. So when you apply 2 here, 2 plus 2 into 2 is 4 plus 1 is 5. So like that. So in general, two variables are said to be linearly related if there exists a relationship of the form y is equal to a plus b into x. A and b are constants and x is the variable. When we change the value of x, automatically y value will get, because a and b has a constant values. Here in this case it's 1 and 2. On the other hand, the relationship between the two variables is said to be non-linear or curvilinear if corresponding to a point change in one variable, the other variable does not change at a constant but a fluctuating rate. Examples of nonlinear correlations is given by the following data set in figure 19.6. So, and in this example in figure 19.4, there is fluctuating, not constant change in the values of y corresponding to a unit in the value of x, and thus it represents a non-linear correlations. You would like to know how to study correlations. Let us briefly discuss the method of studying correlation. But before going on to methods of studying correlations, let us complete the reflections and actions 19.1. So reflections and action 19.1. Relating to your hypothesis, draw the figure of its positive and negative correlation. Next, draw another figure of perfect positive and perfect negative correlations. In addition, draw two more figures of constant change reflected in the entire range of values and non-linear correlation. You may take help of figure 18.1 and 18.4 in the text above for drawing your figures. So now let us look at the methods of studying correlation. The various methods to determine whether there is a correlation between two variables are: one, scatter diagram; two is graphic method; third is Pearson's coefficient of correlations; and fourth is rank method; fifth is concurrent deviations method; and sixth, method of least squares. Of these, the first two are based on the knowledge of diagrams and graphics, and the rest on mathematical tools. Of the several mathematical tools used, the most popular is Pearson's coefficient of correlations are, and thus we will focus on this method. The procedure is different from calculating correlations from grouped and ungrouped data. So 19.3, method of calculating correlations of ungrouped data. There are various methods for calculations of the coefficient of correlation from ungrouped data, using actual mean, using assumed mean, direct method. The use of all this method is illustrated with the help of the following example. First of the find out the correlations and coefficient Pearson's between the age at marriage of husbands and wives using the following data in figure 19.6. So here the value, here the case, first case is between the husband of age 28 and wife. So okay, find the corresponding person between the age at marriage of husbands and wives using that data. So this is husband's way. In case 1, the husband's marriage age is 28 and wife's marriage age was 28, like that. Case 2, it's 25 and 23. Case 3, 24 and 21, like that. So we have for correlations coefficient between the age at marriage of husbands and wife. So method of calculating the correlations coefficient using the actual mean. You would first learn the method of calculating correlations coefficient using the actual mean, and then you would actually carry out the calculation itself. The formula used for calculation is R. R is equal to sigma xy by n into sigma plus into sigma y. So where x is equal to x minus mx, in which mx is the mean of variable series of x values, y is equal to y minus my, in which mi is the mean of series y values, and 6x is a standard deviation of series 6y, standard deviation of series y, and n is the number of pair observations. This formula can also be expressed as r is equal to 6xy sigma 0x2 and 0x y square. The following steps elucidate the calculation of coefficient of correlation. One, take divergence of x series from the mean of x and denote them by x. Square these deviations and obtain the total 6x square. Take deviation of y series from the mean of y and denote them by y. Square these deviations and obtain the total, that is y square. Multiply the deviation of x and y and obtain the total sigma xy, and substitute the values sigma x square, sigma y square, and sigma xy in the above formula. Calculation and correlation coefficient using actual mean. After learning the method, let us now make the calculation and reflect it in figure 19.6. So this is the table of calculation, and we can figure out here, from here is the calculation of correlation coefficient using actual means. Now we have to calculate the value of r, that is the formula is given is r is equal to the sum of xy, and then we have these values here. So whatever this is the formula, as also expressed in sigma xy, that is the sum of xy, and divided by the sum of deviation square x square in x and y. Okay, so that values we have already calculated in this column. So if we are substituting those values, we will get the respective r value. So it has come as 0.914. So method of calculating correlation coefficient using assumed mean. The only difference in this method as compared to the above method is that in the formal the deviations are taken from the actual mean, and this case from the assumed mean. That is, by looking at the series of x and y, assume means for x and y are proceeding in the same manner. Calculation of correlation of or coefficient using assumed mean, you would now calculate as per figure 19.7. So this is the table for that calculation, and we can find out the value of r again using this formula. So we get the value of again 0.914. So a direct method of calculating correlation coefficient. The coefficient can also be calculated by taking actual x and y values without taking deviations. So that is a direct method of calculating it, either from the actual or assumed mean. The formula for it calculation is given below. So if you are substituting those values, we will get into this. So the direct method gives the same answer as one gets when deviations are taken from the assumed or actual means. The examples demonstrate this point in figure 19.8. So this is the values of x square and y square and xy. Those are directly from the xy values only we are taken it. So let us now complete reflections actions 9.2 and then learn in section 19.4 the method of calculating correlation of group data. So reflections and action 19.2 is that select one of the following two calculations and carry it out in relation to your hypothesis. You need not worry about making mistakes in your calculations. At the moment, the idea is to learn the procedure. This is not be a part of your report. One calculation of correlation or coefficient using assumed mean, and calculation of correlation coefficient using direct method. So this is the reflection and actions to be done. So next we will go to the other part, that is 19.4. Method of calculating correlations of group data. So with the large number of observations, the data is concealed in two ways, frequency distributed called correlation table. The class intervals of y series are written as column heads and that of the x series are written as row heading. The frequency of distribution for the two variables is written in the respective cells. The formula for calculating the coefficient of correlation is, this is the sum of f frequencies into dx into dy minus all bracket of sigma fx and deviation, and then sigma fy and deviations divided by n. So we will read the steps for that. That is, take the first step is that take the step deviation of variable x and denote this deviation by dx. Take the step deviation of variable y and denote this deviation in dy. Multiple dx and dy and the respective frequencies for each cell, and write the figures obtained in this right hand upper corner of the cell. Add together all values to obtain the sum of frequency dx and dy value, and multiply all the frequencies of the variable x by deviation of x and obtain the total value, that is sigma fx into di. So take the squares, then take the squares of deviations of the variable x and multiply by respective frequencies to obtain the sum of f, that is fx dx square. It's already squared, actually squares of deviation. Then multiply all the frequencies of the variable y by the deviation of y and obtain a total. Now again you multiply it with the dy for that value, for the y frequency. Okay. Take the squares of the deviations of the variable y and multiply by the respective frequencies to obtain sigma phi and dy square. So same as in x, we are also obtaining the value for y. Then we have to substitute these values in the formula to get the value for. Let us now take an example of to calculate the Carl Pearson's coefficient of correlation using the data in figure 19.9. So these steps we are applying in this table. So we can see the expenditure of luxury items. It's given is there between the income in thousands. So those people have income in thousands of rupees. Okay. So those people having the expenditure in the luxury items, it's shown as 28,000. Those people have an income of 20 to 25,000. What? No, this is a number of luxury items. Who have a number of luxury items from 0 to 4, having these in the income group of 20,000 to 25,000, having 28 of such luxury items. I think so. 28 persons having such kind of luxury items, and those people have 4 to 8 luxury item. Have 41 people in this income group, and 25 people in this income group, and 30, 35, 28 people in this income group. So you can see from this, the people having more luxury items have come under this more income group. So people having 30 to 35,000 income, they have luxury items. This many people are having this. Okay. So this many household have this 16 to 20 items. People from 30 to 35,000 income group. And the people having 39 families of 35 to 40,000 income group have this much items, 60 to 20 luxury items they have at home. And this is the way you can read the table. So from this we can calculate the correlation of coefficient in group data using direct method as seen in figure 19.1, 19.10 and see figure 19.10. So here you can see that the expenditures of items and their distributions, and we can also see that various values calculated according to this in this table. So now we have the further calculation of fx, f, dy, dx. So these all values already here calculated. So based on those values, they reached this value, and they put in there in that formula. We can get the value of r as after calculation. We can get the value of r as 0.682. So most of the variables shows some kind of relationship. With the help of a correlation, one can measure the degree of relationship between two or more variables. Correlation, however, does not tell us anything about the cause and effect relationship. Even a high degree of relationship does not necessarily imply that a cause and effect relationship exists. Conversely, however, the cause and effect relationship or functional relationship would always result in the expression of correlation. We will now discuss regression analysis. 19.5 Regression. Regression analysis is the method of estimating the values of a variable from the knowledge of one or more variables. The variable that the researcher tries to estimate is called dependent variable, denoted as y, whereas the variable used for prediction is independent variable, denoted as x. In a regression equation, there may be one or more independent variables, but if there is only one dependent variable, depending on whether there are one or more independent variables, the regression equation is called simple or multiple. The term linear is added if the relationship between the dependent and the independent variable is linear. Thus, a simple linear regression equation is represented as y is equal to a plus b into x, where y is the dependent variable, x is independent variable, a is a regression constant, and b is the regression coefficient. It measures the change in y corresponding to a change in x. So similarly, the multilinear regression equation is represented as y is equal to a plus b1 x1 plus b2 x2 b plus bn xn, where y is dependent variable. x1, x2, xn are independent variables. A is the regression constant and b1, b2 are the respective regression coefficients. So like the calculation of coefficient of correlation, there are various methods of calculating the regression equation also. First is from actual means values of x and y, also from assumed mean values of x and y. So calculation of regression equation using actual mean, the first method. So regression equation of y on x can be calculated using the following formula. So this formula is already given here. Y minus my is equal to by into x minus mx, or the other one with the standard deviation also given. So the regression equation may be calculated using the formula this also, and you know all the values where x and y are dependent and independent variables respectively. Then in mx and my are means of y and x variable respectively. So the following equation illustrates the calculation of regression equation. So we can calculate the regression equation using the following data, taking age at marriage of husbands and independent variable, and that of wives as a dependent variable. So this table gives the values, and the calculation table is given below. So corresponding values are calculated and put in the equation, then we will get the regression. So as this, and regression form is like this. So calculation of regression equation, this is equation y is equal to is a constant, and this is the coefficient, regression coefficient, and variable x. So this regression equation using assumed data, and regression value of y on x can be calculated using the following formula, taking the assumed mean. So this is the second method using assumed means. So that is the only difference here, but the calculation is almost same type because all values are taken, and calculation table also put accordingly, and substituting the values we will get the corresponding regression equation. So standard error of estimate the perfect prediction using a regression equation is not possible except when correlation value is -1 or +1. Thus the researchers interested in finding the accuracy of estimation of a regression equation. So standard error of estimate measures the error involved in using a regression equation as a basis of estimation. It can be calculated using the equation SEE, standard error estimation, and y is the independent variable, yc is the predicted value of y, n is the number of observation, and these values, if we substitute in this, you will get the regression equation. So coefficient of determination r square is the square of correlation coefficient r, and is often used in interpreting the value of the coefficient of correlation. If the value of r were 0.8, then the coefficient of determinations of or r square would be 0.64. This would mean that 64% of the variance of one variable that is dependent is explained in terms of the other variable independent. So reflections in this and action in 19.3 is I tried to understand how to make the calculation of regression equation using assumed mean. I could not succeed. Maybe you can explain it to me with an example. Write out on a separate sheet of paper your explanation with 1 or 2 examples, Maybe I will then follow it. You will need to send it to the coordinator MSO 002. So this is the reflection and action. And then 19.6 we will go to conclusion. So unit 19 is the last unit of the block 5 on quantitative methods. All 5 units of this block have emphasized that quantitative methods should be used in social research when they are necessary and relevant and can provide superior result. Sometimes you can use them in combinations with the qualitative methods. You need not avoid the quantitative methods because of lack of information or apprehension that is difficult to understand them. The 5 units of block 5 have provided you an appropriate examples wherever possible and necessary to help you to understand the tools that are very useful in your research project assignment. If you want to have further reading, there is books like from Robert B. Burns, Introduction to Research Methods, and other book is Statistics for Social Research from Cohen Lewis and Michael Holiday. So thank you very much. This is the end of the blog.